Hi, everyone, this is the Encyclopedia Channel. The book that this program interprets for you is Across Parallel Universes. The author of the book, Max Tegmark, put forward an amazing theory that is, parallel universes are not just science fiction, the concept in the film is real. So, what are parallel universes? What exactly is the four-level multiverse proposed by Tegmark? Where are we in the parallel universe? In our lifetime, can we meet the self in the parallel universe? After watching this film, we will know the answers to these questions. What are parallel universes? Let's use an analogy. Imagine that in another time and space, the world is the same as ours in every aspect, but the difference is that there is no organization similar to the European Union in that time and space, or Hitler became a great artist, so the historical development of that society presents the same. We have parallel, but completely different trajectories. This is the parallel universe. Sound incredible? Have you ever wondered if there is another you in the universe hundreds of millions of light years away? Maybe you have made different choices at critical times in your life, so you have embarked on a completely different life path now. Maybe you also had regrets. If God can give you a chance to start over, would you accept it? In the past, we would say that it is a pity that there are no ifs in life. But this book tells us that, far away in time and space, another you, no, infinitely many you, are facing the same life choice. The author of this book, Max Tegmark, was born in Sweden and is a tenured professor of physics at the Massachusetts Institute of Technology. He once wrote a best-selling book, Life 3.0, on artificial intelligence, and also founded the Institute for the Future of Life related to AI. However, he also has another important identity, that is, he is an authoritative expert in the field of parallel universe theory research. Tegmark wrote in the book that many years ago, parallel universes were just a somewhat weird concept, but since the 21st century, the scientific community has begun to take this topic seriously. The conclusion of most people is that parallel universes must exist, and there is nothing to doubt about this. The real question is how many layers there are, and how many types of parallel universes there are. This may sound crazy, but with the development of science today, we can indeed use the cutting-edge knowledge of physics and cosmology to explain the parallel time and space in science fiction. Professor Tegmark stands at the forefront of physics and the boundary of the universe, showing us the theory of a four-layer multiverse. He told us that the universe we live in is just a small corner of the vast space, and other universes are hidden in places that are invisible to our naked eyes and even undetectable by technology. In addition to parallel universes, this book involves a large number of complex cosmological theories, including dark matter and dark energy, quantum mechanics, mathematical structures, etc., with a very high degree of difficulty. But for starters, it's still about figuring out what the four layers of the multiverse really are. Next, the book will be interpreted in two parts. In the first part, the bottom-level theoretical support of the parallel universe model will be introduced, which is the theory of inflation. If you want to understand parallel universes, inflation theory is our necessary theoretical knowledge. On this basis, the second part will explain in detail what the four-layer multiverse proposed by Tegmark is. After reading this book, the biggest feeling is that the ever-changing scientific research is subverting our cognition. Today, we seem to be standing at the critical moment when Copernicus put forward the heliocentric theory. In the next few decades, our understanding of the perception of the world may be about to undergo a radical change. First part. Before embarking on a trip to parallel universes, let's first understand this theory of inflation. The storm is the storm of the storm, and the inflation is the inflation of the inflation. Tegmark said that, like the big sale day that always gives away some samples when you buy something, parallel universes are actually incidental items in the inflationary gift package. Inflation theory sounds strange at first, but in fact, inflation theory is related to the familiar Big Bang cosmology. We know that the universe began with a fiery Big Bang. How was this discovered? In 1929, the American astronomer Hubble observed that the galaxies around us are moving away from us, and the receding speed is proportional to the distance, that is to say, the farther the galaxies are from us, the faster they are moving away from us. This is the famous Hubble's law. This observation confirmed the expanding universe theory proposed by Russian physicist Friedman in 1922. Tegmark said that just as Newton proved that the natural state of the solar system is eternal motion, such as the Earth and the Moon cannot remain static forever, Friedman's research also revealed that the natural state of the universe is eternal motion. So how does the universe move? Friedman's theory of an expanding universe tells us that all separate objects are moving away from each other. The author gave a vivid example, just like a cake in the oven, as the cake continues to expand, the chocolate chips on top of the cake are also constantly separating. In this theory, there was a time point in the past, the universe was in a state of high temperature, high pressure, and high density. Everything we see now is at the same point. We call this point singularity. The universe expanded from the singularity in a Big Bang. But unfortunately, Friedman proposed this theory of the expanding universe in 1922, which was too advanced for the people at the time to be ignored by the public. It was not until 1946 that the physicist Gamow formally proposed the Big Bang theory and calculated that the universe was formed by a Big Bang about 13.8 billion years ago, which established the status of the Big Bang cosmology in the scientific community. Let us turn back the time to 13.8 billion years ago, when the universe was hotter than the core of the sun, with an almost uniform distribution of hot plasma. Plasma is the state of gas under high temperature and strong electromagnetic field. The universe expanded rapidly from the singularity, and during this process, the temperature slowly dropped. After 400,000 years, the same thing as the surface of the sun began to happen during the expansion of the universe, that is, to emit light. The luminescence produces a kind of electromagnetic radiation, which we call the cosmic microwave background, or it can also be called the cosmic microwave background radiation. Note that the cosmic microwave background is a remarkable discovery. This kind of radiation fills the entire universe. Through it, scientists can measure the radiation temperature of the universe at different times. If the longer the time, the higher the temperature, which can indirectly confirm the Big Bang theory. We know that according to the Big Bang theory, the universe expanded from a singularity, but according to the observations of scientists, the temperature of the cosmic microwave background radiation is almost the same in all directions in the universe, and the difference can be as precise as 5 decimal places. If the Big Bang happened in one location, then the radiation temperature in that direction should be higher than in other places. But this is not the case. The uniform radiation temperature seems to tell us that if the origin of the universe is the Big Bang, then this explosion should happen in all places at the same time, at infinitely many points. This sounds too sensational. How about the Big Bang? Could it be happening everywhere at the same time? This is the so-called horizon problem in cosmology. The horizon is the horizon of vision, the horizon is the boundary of the boundary, and the horizon is the farthest area that we can observe. But is it possible, the authors say, that some physical process unified the temperature long after the Big Bang? He gave an example. When you pour the milk in the refrigerator into hot coffee, the temperature will reach a uniform warm state after a while. But more importantly, this mixing process takes time, and distant regions of the universe simply don't have time to mix with each other. Therefore, the traditional Big Bang theory cannot explain this strange horizon problem. At this point, inflation theory should come into play. Why do we emphasize this theory? Because the theory of inflation can perfectly explain why the radiation temperature from all directions of the universe is uniform, and on this basis, it leads us to glimpse the truth of parallel universes. In 1980, MIT physicist Alan Guth proposed the theory of inflation, which was calculated strictly based on Einstein's general theory of relativity. Guth believed that the universe expanded at a very high rate during the initial period of time, and this rapid expansion process is called inflation. Remarkably, the rate of inflation is similar to our early growth rate in our mother's womb. Every day at that time, each of our cells basically produced 2 cells, so the total number of cells doubled every day, from 1, 2, 4, 8 to countless. This growth rate is amazing of. But when our cells double to a certain size, we will usher in a more leisurely deceleration phase of growth. The same is true of the growth process of the universe. The initial stage of the universe was a stage of accelerated growth that doubled continuously, followed by a more leisurely stage of decelerated growth. The author emphasizes that this inflation process happened in a flash. How fast is that? According to the calculations of the Guth team, The universe has grown by 10 to the 26th power in less than 10 to the minus 35th power second. This is equivalent to saying that the universe expanded from a particle to the size of our observable universe in an instant. The theory of inflation tells us that all matter was squeezed into an extreme close together in the early days of the universe, so at that time they had enough time to reach thermal equilibrium, like iced milk mixed with hot coffee, to reach a uniform temperature. Later, the expansion brought about by explosive inflation separated the matter forever. The author also uses the development of human cells as an analogy. Just as the cells on your nose and the cells on your toes have the same DNA, regions far apart in the universe have the same characteristics and temperature, originated from the continuous doubling of a fertilized egg. Similarly, very distant regions of the universe have a common origin, all from the continuous doubling of the original small ball of inflating matter. This not only explains the horizon problem mentioned above, but also solves other defects of the Big Bang theory, so I won't go into it here. What's even more shocking is that the authors say that this inflation has never stopped, creating new space forever. This sounds crazy. Didn't we say that our universe first went through a period of rapid inflation and then entered a period of slower deceleration? This is true. We know that about 13.8 billion years ago, in the universe we live in today, inflation did stop. Note that it says our universe. There are some special physical processes in our universe that can get rid of inflating matter, but the nature of inflation itself is never stopping. This is what cosmologist André Linde named eternal inflation. Eternal inflation is like countless balloons that keep inflating but cannot be blown. With the deepening of research, scientists have discovered that even the Big Bang is only a small part of something bigger. The event we call Big Bang is not the beginning of the universe as we thought in the past, but just the beginning of the universe. The end of inflation in our single universe. What does it mean? This means that, outside of our universe, inflation will continue, and it will continue forever, giving birth to an infinite number of universes. The second part. We've had a brief look at inflation theory. It can be said that if you understand the theory of inflation, you will understand half of the parallel universe. In the next part, we will get to the real topic of this book. Welcome to the parallel universe. As we said earlier, outside the universe we live in, there is still a vast space that is expanding infinitely, just like unbroken cells, thus giving birth to infinitely large and infinitely many universes. And the parallel universes of the first level and the second level are originated from this kind of eternal inflation. Let's look at the first layer first. Simply put, the first level parallel universe is similar to our universe, where there are galaxies, planets, Earth, and even the same forests, lakes, and hills as ours. This parallel universe is so far away that the light emitted there has no time to reach the Earth, so humans cannot observe it, and it is impossible to contact it. So, what is the experience of living in the first level parallel universe? For the inhabitants of the level 1 parallel universe, the laws of physics are the same for them as we are, but their initial conditions are different from ours. How can this be explained? Tegmark said that the same laws of physics mean that we may have the same conservation of energy, gravity, etc., but our initial settings, such as the positions of particles, are slightly different, and it will completely rewrite the history of the universe. To put it simply, the students in the first level parallel universe learn the same content in physics class, but the content in their history class is completely different. Perhaps in their universe, dinosaurs did not become extinct and human beings did not become extinct. It took millions of years to appear, or maybe as we said before, Hitler became a great artist, there was no European Union organization in Europe, and so on. Let's go back to the question at the beginning. So, in the parallel universe, is there another you? The answer is yes. According to the predictions of inflation theory, the other you is in the level 1 parallel universe. Why so sure? Tegmark tells us that in the infinite space created by eternal inflation, as long as it obeys the laws of physics, it will definitely happen, and the number of times it happens is infinite. How to understand this? Like rolling a dice, even the most unlikely events are bound to happen if you roll the dice enough times. Therefore, in infinitely many parallel universes, there will always be a person who is exactly like you, has experienced the same life, and lives on a planet exactly like the Earth. You may ask, can we meet the self in the parallel universe in our lifetime? According to the author, first of all, if you want to find two identical universes, you may need to check 1010 and 118 universes one by one, which is a huge astronomical number. It's almost impossible to be that big. Second, the distance between us and the parallel universe is very far away. Although it is a pity, with our current capabilities, no one can observe any parallel universe. Third, the speed of eternal inflation is too fast, and the progress of human observation equipment may never keep up with the speed of inflation. As the author said, human beings are like living in a mist, and there are infinite worlds beyond the edge of the mist, but we cannot measure or reach them. Our observable universe is already vast, but it is only multidimensional. A small part of the universe. Speaking of this, we have finished talking about the first layer of parallel universes. Before revealing the remaining 3 multiverses, we need to clarify the difference between the parallel universe and the multiverse in the book. The reasoning is similar, we just need to know that the first layer of multiverse is the sum of the first layer of parallel universes. Sometimes the two words are used interchangeably in the book, and we continue to use this practice here. Next, we enter the world of the second-level multiverse. Have you ever wondered why, in our observable, vast universe, only the Earth gave birth to life? We know that the emergence of life requires many harsh natural conditions, such as suitable temperature, humidity, oxygen, and so on. If the sun's light is stronger, the temperature of the Earth may be as high as hundreds of degrees Celsius. If the gravity of the Earth is lower, we may not be able to reproduce. From the microcosm of particles to the mass of the sun, our universe seems to have undergone some kind of fine-tuning, the authors said. As long as there is a slight difference in one item, there may be no Earth at all. This is the fine-tuning of the universe. So why is this all just at the right value to allow life to emerge? It's as if they've been fine-tuned by a pair of all-powerful hands. Is it just a coincidence? Or does God really exist? Probably neither. The author infers the existence of the second-level multiverse from the fine-tuning of the universe. In the second-level universe, those seemingly fine-tuned values have changed, which means that the laws of physics we are accustomed to have changed. What does it mean that the laws of physics have changed? Let's take a popular example. If a fish lives in the sea all its life, water is not a medium for it, but just an empty space. From the fish's point of view, the properties of water that humans see, such as the frictional force encountered when swimming, are fundamental laws of physics, just as air is to humans. Did not know that water has 3 different states, that is solid, liquid and gas. To go deeper, these different solid, liquid, and gas states are called phases by physicists, and phases are phases of appearance. From a fish's point of view, it's hard to know that the so-called empty space it feels is really just a liquid phase. So, it's the same for us humans. Since the Big Bang, we've been subject to some unchanging laws of physics, and maybe we're like fish, never realizing that there were other possibilities. But in fact, is the space we live in just some kind of medium? Tegmark tells us that this idea is not fantasy at all, but the result of scientific research. What is certain is that the space we live in is just a medium. Not only that, but this medium also has many states, far greater than the 3 phases of water. So, how many kinds of media are there in our space? Research has proved that there are about 10 to the 500th power, or even countless states. You see, how human limitations limit our imagination. Just like fish living in the sea cannot witness the solid and gaseous states of water, we cannot imagine what the medium we are in can become. So, here comes the problem. What creates the space of so many different states? The answer is still eternal inflation. To cause a phase transition in space, that is, a change in the state of space, requires a lot of energy, the authors say. And this is an energy that we humans do not have, only inflation can do it. Back in the early days of inflation, every tiny space contained a huge amount of energy, enough to trigger random phase transitions. When this small space rapidly expands into a huge area, its interior will have the same physical laws, which is what we said before the first layer of multiverse, and the areas with different physical states caused by phase transitions form the second layer of the multiverse. If the laws of physics were changed, that parallel universe would be very different from ours. In other words, if life appears in that universe, it may look very different from us, and maybe it will have superpowers such as traveling through time and space or teleporting. So, can we reach the second level of the multiverse? According to Tegmark, this is impossible. Some regions would cease to inflate, as in our universe, while others would undergo perpetual inflation, rapidly creating infinite space, thus spawning isolated regions of spacetime into a tree-like structure. In this case, the U-shaped region between the branches is just the product of the end of inflation, and each such U-shaped region is filled with infinitely many level I multiverses. The tree will continue to grow, like new branches, creating an infinite number of such U-shaped areas. So, even without looking at the distance, we are separated from the second multiverse by eternal inflation, so we will never be able to pass through the branches of the tree to reach those multiverses with different physical laws. In short, the state of space and the laws of physics in the second-level multiverse are very different from ours, and it is another world that we will never be able to reach. Now, we're done talking about the level 1 and level 2 multiverses, and that's not the end. If the first two layers of universes are both macroscopic and related to eternal inflation, then you can temporarily forget about inflation theory, because the third layer of multiverse will bring us back to the microscopic scale. Tegmark told us that the third-level universe is called quantum parallel universe and exists in an abstract space called Hilbert. Hilbert space, to put it simply, is a space with infinite dimensions as opposed to three-dimensional space. This is a concept in physics. If you are interested, you can search it online, but here, our focus is to understand what the third-level parallel universe is. We know that there is a thought experiment we are familiar with in quantum mechanics, that is Schrödinger's cat. The author explains it like this: the cat is locked in a box, and a jar of highly poisonous cyanide is placed in the box. The switch of the jar is connected to a radioactive atom. If the radioactive atom decays, the jar will open and release the cyanide. Kill the cat. But since the decay of an atom is a random event, we don't know whether the cat is dead or alive. The classic Copenhagen interpretation holds that a cat becomes either alive or dead only when we open the box and observe the cat for ourselves, but until the box is opened, the cat remains in a superposition of both alive and dead, which means neither life nor death. But this explanation does not match our common sense. How can a cat be alive and dead at the same time? Therefore, physicist Everett proposed another more convincing explanation, that is, parallel universes, which is also known as the many worlds interpretation. In simple terms, when you look into the box, the cat simultaneously splits into two different versions, both real, one alive and the other dead, but in two different quantum parallel universes. The two universes are identical in all other respects, the only difference being that in one version the atoms decay and the cat dies, while in the other version the atoms do not decay and the cat lives. Also, the cats in the two versions are unaware of the other's existence. It seems like we've been talking about cats all this time, but this thought experiment should not be underestimated. This conclusion applies to you, me, and our universe. The authors estimate that this split started at the moment of the Big Bang and continued continuously, rapidly splitting into countless quantum parallel universes. In other words, we may be split into countless parallel universes at the moment of birth. Theoretically speaking, all the possibilities of our life have become reality in the quantum parallel universe. It sounds unbelievable, and you're probably already banging on tables in protest. How is it possible that we are constantly splitting into an infinite number of selves? At least we don't feel it at all. But Everett gave us a wake-up call. This reminder is simply deafening. He said, "Can you feel yourself revolving around the sun at a speed of 30 kilometers per second? Obviously not. If you told that to an ancient man, he would think you were crazy. We are the same, our thinking is imprisoned in the limitations of the times, so we cannot deny the existence of quantum parallel universes just because we cannot feel it. To borrow the author's words, it is, the real world we live in is indeed grander and larger than the wildest and unruly dreams of the ancients. Perhaps we can't imagine what people's cognition of the universe will be like in the future. Therefore, we should maintain an attitude of awe and humility. Perhaps one day in the future, scientists will be able to confirm the existence of quantum parallel universes. The first three layers of parallel universes are hypotheses that have been discussed by the scientific community for a long time, while the fourth layer of universe was first proposed by Tegmark himself, which is his mathematical universe hypothesis. This is not only one of Tegmark's biggest breakthroughs in the professional field, but also the most daring and abstract of the four parallel universes. He believes that the universe is not just described by mathematics, the universe itself is mathematics. Everything we know is composed of mathematical structures, including you and me. Just like our space is three-dimensional, 1 plus 1 is equal to 2 instead of equals 4, the formula of the parabola is always the same as y equals x caret 2. It sounds crazy, but it's not without logic. From a microscopic point of view, the author believes that when we peel off the layers of appearance and see the ultimate structure of existence, we will find that there are no so-called intrinsic properties like color and texture, but only numbers, a series of abstract mathematical relationships such as sets, information, and patterns. From a macro perspective, mathematical structures are eternal, and they do not exist in time and space, but time and space exist in mathematical structures. Therefore, the first three layers of multiverses all follow the same mathematical formula, while the fourth layer of universe involves different formulas, corresponding to different mathematical structures. Although this hypothesis is currently only at the theoretical stage, it has opened up an ultimate brain hole for the physics community. Due to the large amount of terminology and calculations involved, and limited space, we will not expand here. If you are interested, I recommend you to read the original book. In short, the mathematical universe hypothesis is Tegmark's ultimate thinking about the world, and perhaps this is also the ultimate form of parallel universes, and the parallel universe beyond that is beyond the reach of human imagination. The essence of this book is here for everyone to interpret. Let's summarize what exactly is the four-layer parallel universe popularized by Tegmark for us. The first layer of parallel universes is similar to our universe, but outside our observable range. These parallel universes have the same physical laws as ours, but may have different cosmic histories. The second layer of parallel universes can never be reached. The space between us is separated by eternal inflation, and these parallel universes have different physical laws from ours. The third layer of parallel universes, that is, quantum parallel universes, exists in the Hilbert space with infinite dimensions. The four-layer parallel universe is a mathematical universe, and everything is mathematics, and the difference in mathematical structure has derived countless parallel mathematical universes. In the face of the boundless universe, human beings have to lament their own insignificance. Compared with the long cosmic time, how insignificant our short history is. But Tegmark said that our short century may be the most important period in the history of our universe. Technology is developing rapidly. We have more and more powerful technology, enough to destroy ourselves, but we may also destroy life. Seeds are sown in the universe. The leading physicist reminds us that we may now be standing at a fork in the road to a future in which, if we choose to survive, we will shape the universe and future life on Earth will be grateful for what we have now. Decision made. In the vast space of the universe, the existence of human beings seems insignificant, but for our own universe, we undertake an important mission. Perhaps as the author said, it is not the universe that gives life meaning, on the contrary, it is life that gives meaning to the universe. This is the end of this episode of the show. What do you think about it differently? Welcome to leave a message to discuss with everyone. Hey, if you like our channel, please subscribe us. Haha, remember to like it.